Alright, so today what we're going to be doing in the background, you can see my Delusional Design CNC plasma table. It's a 4x8 table. I picked it up, it's been a couple months now, it's probably been 4 or 5 months. Picked it up, not working, was told it's got a dead servo. I got a steal on this table. Did a little diagnosis in the last few weeks, replaced the servo, just listened to the guy, whatever. Still had the same issue, and that issue is one side of the x-axis when you went to travel would jog back and forth. Occasionally it would go the right way, occasionally it would go the wrong way, or it would just stall completely. But once it was moving, it would continue in the path of travel like it was supposed to. So I'm going to show you guys, I pulled the servo off table. I've still got the new servo wired in. Turns out the old servo's fine. It's actually a better quality servo, so I'm going to put that back on. But I will show you guys how I came to the conclusion that I did. Alright, so we got repeater host fired up, table all powered up. These are pretty interesting. They use a Mechatronics V2 3D printer board and these Nemo 17 servos, 3D printer stuff. So the way they do this is you have an x-axis servo motor, stepper motor, it's actually a stepper motor on either side of the table, ran through this 4-wire AWG stranded shielded cable, burglar wire. And what they do is on this board, if you can see it, you have your Y motion, your X motion, your Z motion, your extruder. They loop the extruder to the X servo circuitry, so you can run 2 X servos, stepper motors. I keep calling them servos. So what I found was this is disconnected, but it's all wired up. I get the cable pulled out because I'm running a new one. But go -10 here. So turns the right way one time. Now I'm going in the same direction, and you can see this is jogging. This is why I replaced servo. This is why the previous owner thought the servo was bad. But what I did was take the original servo from the table and put pins right on it. I already cut them off. And then connect it directly to this board, wondering if it was a bad board. I found that the servo operated correctly, so my assumption now is this cable is bad. Easy enough fix. We're going to put in a new cable today, put a new end on it, solder it to the original servo, because it's a better servo than the replacement servo I bought, put it back in, and see if it runs correctly. Alright, so we got a cable actually ran through. My buddy gave me a piece of cable because I was having a hard time finding replacement cable. The one he gave me was a little too short though. Ran it through the power track and it just doesn't have the reach to reach up and follow the correct path. So what we're going to do is just tape this to our new wire versus taking apart the power track and running it all through. We'll just tape this up and run it through using the old cable to kind of snake it. Further down on this side as well. Alright. Alrighty. Take this, and we'll just kind of wind myself this way. Something like that. Very carefully pull our cable through here. And we have it. Okay. That blue tape does hide its end extremely well. There it is. I'm gonna leave this tape on here and just see if we can reuse it. You've got where the original cable that runs the original servo. Actually, we're just gonna pull this off. Alrighty. I didn't want that to hit the ground, but I guess it's gonna stay on the ground. Alright, so now we got our 4-wire cable pulled up here, 22 gauge. I'm gonna very carefully strip the outer casing. Notice I'm using a size that is far bigger than the casing altogether and stuff. Even if we gotta run it around a few times, we know it's not going to cut into our inner wires. So we do that. Now we're gonna strip our shielding back, which may prove a little harder than I expected, actually. There we go. Alright, so we're gonna strip our sheathing back here, or shielding I should say. And we'll go ahead and just trim that right off. I guess I should go get diags for this. Alright, so we'll do that in a second. But you got essentially 22 gauge 4 cables in here. So we are going to solder this to the 22 gauge 4 cable on the servo. So we'll go ahead and just strip it back a little, enough to solder. We got our 22 gauge on the stripper. Go back about that far. These are times I wish I was born with smaller fingers. Two. Three. And 4. Alrighty, so we'll get that stripped. And like I said, what we're going to do is we're actually going to put the original servo back on this as well, which is right wherever I put it. Oh, here. So we got our 4 cables here all separated out. And our new wires, it looks like the only thing that doesn't match up is the blue. So we'll put the blue to the white, and we just got to remember that when we go to do our end on the other side. Okay. Probably isn't the best way to solder wires, but these are really short, so I'm kind of having a problem getting them in a good position here to interlink them and work the solder and all that. So this is something my dad showed me years ago, soldering some small wire. You kind of use the solder. I know you can't see what I'm doing because of my fingers being in the way here, but you take the solder and you cut yourself off a small piece and you use it to kind of tie your wires together. You wrap it around a couple times, and then you don't have to work your solder and you just have to work the 2 wires. So then you just heat them up and boom. nice soldered connection. So like I said, we got all matching colors except for we have a blue on this side and we have a white on this side. So we're gonna connect our blue and our white. I'm gonna take my solder and boop, break off a small piece here. And take it, we'll mesh our two ends together here. Bottom right together. Oop, drop my solder. Let's see, can I do this one-handed? Nope, I cannot. This side that's a little long, so take it and we'll do one wrap around that to begin. Then we'll intermesh our two ends here. And we'll stop doing that. We'll stop sliding one end out, hopefully, if we want to get this done. Boop, intermesh our two ends. Take our solder. Do a quick wrap around. So I'm not just putting the two pieces of wire next to each other and doing this. I am pushing them into each other. The goal is the least amount of resistance. Soldering iron's hot if you touch it. Finger, by the way. Ow. Alright, and we're gonna redo that. I'm gonna make it look like I didn't have to. Alright, so now we got all those solder joints done. Slid our heat shrink over and just use a good old Bic lighter here to boop, heat shrunk. Maybe a little more on that end. And last one. Alright, so we got all four of our wires nice heat shrunk, connected, soldered on the servo side. Now we can go ahead with connecting our pins on the other side. Alright, so now we got the other end of our wiring up at our connection box here. Go ahead and just strip all these back a little bit. That's about right. This side we're going to pin for our 4-pin connector. So we don't want to strip them back too far because we don't want exposed wire in our box. We just want enough to put our pins on. Okay, so we got our 4 wires stripped. I'm gonna set you back. Alright, so I'm not exactly sure what you would call these pins, but these are female, that'll focus, square end pins like you'd find on 3D printer, stuff like that. They come on a nice roll like that. What I do know is the Duet style service kit for the Duet connector I use in my day job work perfectly to crimp them. So we just got that, and we got our 22 gauge one right there. get right over the first half of the terminal, and we go burp. Huh? There we go. Burp. Oh, it helped we use the 22 one. That's why it's not doing anything. Alright. Nice strong crimp on the bottom there. Now we'll just crimp our keeper. Boop. Nice strong crimp. So we'll do that to all 4 of these, and then I'll show you guys how we're going to put them in the connector. Alright, so now we got our connector all put together. We will take that and plug that back in to the X-axis. Then we will flip this on, plug this in, connect the printer. Well, let's see. Oh, actually, you're going to be watching the wrong one. Watch this one. It's hard to see, but... And we have consistency. That was the issue. So I'll get that servo bolted back up, and I'll show you guys how the table runs. Alright, so we got everything put back together. All nice and zip tied up, taped. Control panel back together. THC set to 100 volts. It's going to run a little funky just because I don't have a torch in there to actually flip the limit switch. So it is going to run a little funky. Probably hear some grinding, but fairly normal. So let's see here. 48-inch test. And we already zeroed everything out, so print. Nice even run across the table now, which is nice. Here comes that after grinding. But everything is running nice and smooth now. Alright, so driving home, forgot to film an outro. But the plasma table's all back together. Everything's zip tied up nice, heat shrunk, wire loomed, control board put back together, etc. All works as designed now. I did a little test off camera. I took a precision screwdriver and basically blocked it up to stop from hitting the limit switch, and that fixed that grinding noise. That's exactly what it is. It's trying to touch off the torch for the torch height, and it's not seeing that obviously because the limitations of the screw gear stop it about a ½ inch before it actually hit the fins on the table. So that's all working good. Now we just got to get a torch hooked up and we're ready to cut some stuff. Thanks for watching. See you hopefully next time we'll be cutting some stuff.